Hi guys, this is for AMC problem 24, and we have this geometry problem here, and it says Jean has made a piece of stained glass art in the shape of two mountains as shown in the figure below. One mountain peak is 8 feet high, while the other mountain peak is 12 feet high. Each peak forms a 90-degree angle, and the straight sides form a 45 angle with the ground. The artwork has an area of 183 square feet. The sides of the mountain meet at an intersection point near the center of the artwork, each feet above the ground. What is the value of H? Now, this may seem a little bit complicated at first, and you might be tempted to try to find the area by sort of cutting this into pieces, maybe, and finding each individual piece's area. And it's kind of difficult to find the area of like this sort of wonky looking polygon without cutting it, since you can't really, we don't have like a standard formula for this kind of polygon. There might be a couple ways to look at it besides the one that I just did, where you just like cut it into these separate trapezoids, or you might decide to cut it into a quadrilateral of some sort. But this is all kind of difficult to find the side lengths of, especially in this case where you don't know how to get this length here. I mean, I'm sure you can find it, but it's a little bit difficult. So instead, what I would like to do is imagine that we know that it's cut off at this height h for each of these big triangles, right? But imagine that instead of being cut off, they went further like this, right? Which is just like following the line that we created before. I didn't make the first one very good. Let me redraw that just to make it clear that this is a 45 degree triangle here. Sorry, let me get this real quick. And so if it looks like this, right? And we know that this would have been also, both of these would have also been 45 because it continues along our standard line here, right? Because if we extended this line, this would have been 45 degrees, right? Since this is 45, this is 90. If we extended it, it would have been 45. Same with this side, 45. And we know that this is 90 then. And so instead of finding these areas separate or cutting it, I'm going to extend it and then subtract this area here from the large ones. So we know that the height of this triangle here, let me sort of outline it in a different color so we can just get an idea of what I'm doing here. So I'm going to find the area of this triangle here first. And we know that the height here is 8. And if you know anything about 45 degree triangles, if we split it down the middle here, we create another 45, 45, 90-degree triangle because this is 90 degrees, right? Because it's the height. This corner is 45, and so is this is 45. Same thing for the other side, they're equivalent. And we know that for 45, 45, it's isosceles. So this leg is the same length as the other leg. So this is also 8. And so is this. This is also 8. So we know that the area of this triangle should be base times height divided by 2. Our base is 8 plus 8 is 16 times height is 8. And we divide that by 2. Let's do like this, and we get 64 for this area. Now, let's find, oh, let me keep that. I want to find the area of this other big triangle here in the same way. Now that we already know that how to find this 8 triangle, we know that the 12 triangle should be the same. Sorry, that's a bad line. Right angle here, this is 12. This should be 12 and 12. And then we know to find this, we would do 24. Oop, that doesn't really contrast very well. Let me write over here. 24 times 12 divided by 2 is equal to, let's divide like that. That's 12 is equal to 144. So we have a couple areas here. We know that the red triangle here is 64. The green triangle here is 144. And now let's find this blue triangle here. So let's go back to blue. This is the blue I used. And the height is h. We don't know the real height. But we know this variable here, and we know that the base should be 2h following the precedent of these other triangles here. And we can prove it again. This is 90 degrees, so it's another 44, 45, 45, 45. So this should also be h. This should also be h. So it's 2h times h divided by 2. Let's cancel that out, and we get h squared is the area of this triangle. And now let's use our final condition, which is that the total area is 183 square feet. So let me write it down here in a new color, maybe. Let's do dark red. So what we know now is to find the area of this whole shape, we should do 64 plus 144 minus h squared. Since when we're adding these two triangles here, we have this overlap region where we count it twice, which is our h squared region, right? So this equals 183. Now let's try to calculate or simplify to find h squared. So I'm going to bring my equation up here since I don't have much more space. 64 plus 144 should be 208 minus h squared equals 183. Let's subtract 183 from both sides, add h squared to both sides, and we get 26. Sorry. Oh, sorry. 25. I don't know what I was thinking. 208 minus 183 is 25 equals h squared. H equals 5. So our answer should be B, 5. Let's check. Yep. All right, thanks, guys.